Good morning, students. This is your teacher at the course. This class will be talking about salt hydrolysis. What do you mean by salt hydrolysis? Hydrolysis normally occurs when salt dissolves in water and the solution that is formed start behaving like an acid or a base. That is, the solution is now acidic or basic because you dissolve the salt inside the water. This phenomenon is known as salt hydrolysis. That is, salt hydrolysis, some salt entering inside water and then they are breaking down inside the water. Hydro means water. Lysis means breaking down. So that is salt hydrolysis. So this salt, some of these salts, not every salt, I will tell you those salts now, we will discuss those salts now. Not every salt hydrolyzes, but most normal salt hydrolyzes in water to form either an acidic solution or a basic solution. So this process is what is known as hydrolysis. Hydrolysis. That is the process by which a normal salt dissolves in water to form an acidic or a basic solution. That is called hydrolysis. Now, which kind of salt normally form acidic solution? Which kind of salt normally form a basic solution? We are going to see now. Salts that are formed from strong acid and weak base. Salts that are formed from strong acid and weak base. These salts tends to be acidic in water because the acid component is strong. So these salts now, when they dissolve in water, they behave like an acid. That is, they change the color of blue litmus paper to red. Example of such salts are these: ammonium chloride, copper sulfate, aluminum chloride, and a host of them like that. Very plenty of those salts. Now, how do you know if a salt will form a strong acid and a weak base? How do you know if a salt will form a strong acid and a weak base? Now, it is very easy for us to know. Very easy for us to know. Now, let's take an example from this place. Ammonium chloride. See, ammonium chloride is a normal salt. It's a normal salt. It's not acidic, it's not alkaline, it's a normal salt. Now, when you dissolve it in water, this is what happens. Water will break the ammonium chloride. You know, water is H2O, that's H and OH. So the OH aspect will go to the cations, which is ammonium ion, while the hydrogen aspect will go to the chlorine, which is the anion. The minus will attract the plus, like we normally do. So if the NH4 picks OH, you form NH4OH. If the H picks chlorine, you form HCl. Now, you observe that NH4OH is a weak alkali, while HCl is a strong acid. So the overall reaction will be acidic in nature. It will now be acidic in nature. That is one example. Let's see another example. Copper sulfate. This copper sulfate. What do you normally do? Like I told you, you cut it in the center, H2O, OH will go to the cation, that's the metal part. Then hydrogen will go to the negative ion part. So what will you be having? Copper and OH give you copper hydroxide. Then hydrogen and SO4 will give you H2SO4. Now observe that copper hydroxide is a weak base. Why H2SO4 is a strong acid, isn't it? So the solution will behave acidic because the H2SO4 is stronger than the copper hydroxide. Strong, don't forget, to strong means that it will ionize completely. The weak one will not ionize. So if acid is the one that is strong component there, all the acid will be ionizing. And when acid ionizes, what do they form? They form hydrogen ion, right? And that is why the solution is acidic. Because the base is weak, the base will not ionize. And so I hope you are getting that now. So whenever a salt dissolve in water and form a weak base and strong acid, the solution will be acidic because excess hydrogen ion will be produced, which will enable litmus paper to change from blue to red. So that is what you get in that place. Now let's see another example of salt that undergoes hydrolysis. Salt from a weak acid and a strong base. When salts are formed from weak acid and strong bases, you remember, when the acid is weak in this case and the base is strong, it means the acid that is weak will not ionize, while the base that is strong will ionize completely. When bases ionize, what type of ion do they form? They form hydroxide ion, right? They form OH minus. So there will be excess OH minus inside the solution. So what will now happen is that the solution will be behaving like a base. Now let's take an example. Following our normal process, break that in the middle. Water will give OH to the metal part, H to the non-metal part. So what do we now have in that case? So the Na picks up OH, become NaOH, while the CO3 picks up H2, become H2CO3. Now NaOH is a strong base, while H2CO3 is a weak acid. So you will observe that the solution will be basic or alkaline to litmus paper. So another example is also here, K2CO3. K2 will collect OH, so become KOH. Then CO3 will also collect H and become H2CO3. Then the same thing also plays out. The H2CO3 is weak, while the KOH is strong. So the solution will be behaving like a base because the basic aspect is strong, that is, the alkaline component is strong. So the same thing also happens here. In fact, this one is very interesting. The name of this salt is sodium ethanoate. We met it last class. Sodium ethanoate. Now you break it between the metal and the anion. Actually, this is the anion. This is acetate ion or ethanoate ion. Remember that all acetate salt are soluble. Don't forget that. All right. So you put OH. Where do you put OH? Here or here? You put it here, right? Because this is where the metal is. Then you put H here where the anion is. So here will give you NaOH, which is a strong base. This will give you ethanoic acid. The ethanoic acid is an organic acid, so it's going to be weak. So the base component is strong, while the acid is weak. So what do you expect the solution to be? It's going to become basic because it has a strong base and a weak acid. A strong base and a weak acid. So that solution will now be basic to litmus paper. Let's see this type of salts that are formed from strong acid and strong base. They are formed from strong acid and strong base. Now, if a salt is formed from strong acid and strong base, what does that mean? Both the acid will ionize completely and the base also will also ionize completely. So what happens in this case? Where both of them will ionize completely, what will happen? It means that as this guy is producing his own hydrogen ion as an acid, base also produces his own hydroxide ion as a base. So there will not be one producing more than the other, since both of them are strong. So there will not be excess of hydrogen ion and there will not be excess of hydroxide ion. So the solution will not be acidic and will not be basic because the two components are strong. So this kind of solution always have a pH of 7, meaning that the solution does not undergo hydrolysis. Solution does not undergo what? Hydrolysis. For solution to undergo hydrolysis, one of the components must be weak. Either you have a weak acid and a strong base, that will be a basic solution, or you have a strong acid and a weak base, that will be an acidic solution, or both of them are weak. So if both of them are weak, then that's an advanced something. The one that will overcome depends on some parameters that you don't need to bother yourself about. So whenever both of them are strong, pay attention. When both salts are strong, then hydrolysis doesn't take place because there will be no excess sodium or hydroxide ion. So the solution will be neutral to litmus. That is, the solution will have no effect on the litmus paper. No effect on the litmus paper. So let's take a few examples before we eventually call it a day for today's class. Lesson number 1, which in our checkpoint 7, which of the following can be recovered through dry heating? That's evaporation to dryness. I taught you in our last class that salts that do not decompose when you heat them, this kind of salts can be recovered through dry heating. That is, they have high melting point. But there are some salts that normally decompose when you heat them, so you cannot recover them from their solution by evaporation to dryness. That will not happen. The salt will just get destroyed. So if you check my last video very well, I told you that salts that do not decompose when you heat them, they are chloride salts. So they have high melting point, like sodium chloride now. They have high melting point. If you evaporate them to dryness, they will never decompose. So you obtain chloride salt by dry heating. The rest, what you do to them is crystallization. You crystallize them. You crystallize their life out of the solution. So that is that about that. So chloride salt, you recover them by crystallization, by evaporation to dryness. While other salts, surface salt, nitrate salt, all those salts that can easily decompose when you heat them, you recover them by crystallization. Number 2, a major factor that is considered in selecting suitable method for preparing simple salt. The major factor is solubility in water. We did that last video. If you want to prepare a salt, you must know whether the salt is soluble or not. If it's not soluble, then that means you use double decomposition. If it is soluble, then you can use any of the methods available to prepare a soluble salt. Number 3, aqueous sodium chloride, aqueous sodium trisulcarbonate 4 is alkaline. Why? Aqueous, see aqueous. Aqueous means the salt has been dissolved in water. Now, aqueous sodium carbonate 4 is alkaline. Why is it alkaline? The reason is because when the salt enters inside water, it hydrolyzes in water. It hydrolyzes in water. So that is why. And it forms a strong acid and a weak base. It forms a strong base and a weak acid. You already know that. If you break it into two now, even from the word, you can break the word into two. Sodium, we collect hydroxide. This one we collect hydrogen. So we'll be having hydrogen trisulcarbonate 4 and sodium hydroxide. So this one collects hydroxide. So this one collect hydrogen. So you'll be having hydrogen trisulcarbonate 4 at one part, and you're having sodium hydroxide at the other part. If you compare sodium hydroxide and H2CO3, sodium hydroxide is a strong base, so it ionize completely, while H2CO3 is a weak acid. It doesn't ionize completely, so the solution will be alkaline. And why is it alkaline? It is because of hydrolysis that sets in. That's why it is alkaline. Finally, before we go, HCl, NH4Cl, actually it's supposed to be NH4Cl. It should be NH4Cl. NH4Cl. Now, you already know what to do. You break it into half. This part you put OH, so that's ammonium hydroxide. This part you put H. So we have HCl and we have ammonium hydroxide. That thing looks rough. It looks rough. Alright, so we have this. So we have HCl and we have ammonium hydroxide. So ammonium hydroxide is actually weak. It's a weak base, while HCl is a strong acid. So what do you expect of the solution? Should it be acidic? Should it be basic? Or should it be neutral? Of course, it's going to be acidic in nature. So we'll be ending the class here today because I don't want to teach the next topic inside this video. I want to teach the next topic separately. It's called water or crystallization. It has calculation inside. So I will do it step by step so that you don't get lost in the middle. So but make sure that you watch this video very well, maybe 2 or 3 times, because hydrolysis is very, very important in chemistry. So I wish you all the best. Test 8 is already there. So as soon as you finish watching this video and you think that you've understood all the concepts, then go and write your test 8. But if you have not yet understand it, please watch this video again and ask me question online. Then you can trash it out. Then you can go and write the tests. Thank you very much. God bless you. Amen.